Alright, so today we're going to talk about the factored form of quadratics and how we can come up with equations. So if we look at this, we can see where the x-intercepts are just by looking at the graph. So if we think about these solutions, this is where x equals 5, and right here is where x equals -3. So if we think about going backwards, we want to get them equal to 0. What do we have to do to get them solved for 0? So we can set up our equations. We've got x equals -3 and x equals 5. Well, in the first one, I think all we got to do is add 3 to both sides to get it equal to 0. So there's the first factor of our quadratic. And well, the x equals 5, all we need to do is subtract 5 from both sides. And we have our other factor. If you want to think about this like in the last unit, if they're factored, they're in parentheses, and the inside always lies, so we can just flip the sign of the x-intercept to come up with our factors, if that's how you want to think about it. So we end up with x plus 3 times x minus 5. Now there's a couple of other important things we need to find. We need to be able to find the axis of symmetry and the vertex. Then we'll talk about the y-intercept here in a minute. So we need to find the distance between the two x-intercepts because we know the axis of symmetry is going to lie right in the middle of those 2 points because quadratics are symmetrical. So if we look at these two values and we think of this as a number line here, we go from -3 to +5. So we have a distance of 8 units right there. So now we want to say, well, let's average them so we can find how many units would be the middle between those 2 points. So we divide them by 2. So 8 divided by 2 is 4. And you can go from the left x-intercept or the right x-intercept. I like to think of it as subtraction. So every time I do these, I look at it and I say, okay, my right x-intercept is 5. So I need to go back 4 units from 5 to get to my axis of symmetry. So when I do that, I go back to 4, 3, 2, 1. So where x equals 1, that is the middle of this graph, and that's where the maximum value or the minimum value is going to be, and the x-intercept will be. So I can draw my axis of symmetry in here now. Now, if we remember correctly, the axis of symmetry also tells us the x value of the vertex. So we can easily find the vertex now. So since we know that the x value is 1, all we need to do is plug that in to our equation that we came up with earlier and see what the y value is, what the output is. So I'm going to, again, just plug in 1 for x. So I have 1 plus 3 squared times x minus 5 squared equals y. And I accidentally wrote 4 there. Let me fix that. That should be x minus 5, which should be 1 minus 5. I am sorry. Now working this out, now we have +4 times -4, which gives us -16. So that tells us our vertex is at 1, -16. All right, and the last thing we want to think about here is, well, what about the y-intercept? If we think about multiplying these two binomials out, either using FOIL or the box method, our y-intercept is located at that last box we multiply, which are just the two coefficients. Sorry, the two constants. So we just say positive 3 times negative 5, that gives us negative 15. So that's an easy way to find our y-intercept when it's in factored form as well. So keep that in mind. All right, so let's take a look at another example here. Notice this one's opening down, so we have a maximum value here. And we can see that it crosses the x-axis at negative 6, so that'd be x plus 6, and at positive 4, so we'd write x minus 4. Remember, the inside lies. And looking at this right off the bat, we should be able to see that I made a mistake again. I am missing a negative sign on that equation, so please make sure you put a negative out in front of the x plus 6 outside those parentheses. So we can do our axis symmetry by finding the distance between them. It's 10. Divided by 2 is 5, so we need to go back 5 units. So we would be at x equals negative 1 for our axis of symmetry. So our vertex now, we just plug in negative 1 into the equation. And I will fix the equation right now. So we should have that negative out in front because it's opening down. So when we plug in negative 1, we end up with negative 1 plus 6 times negative 1 minus 4. So now we've got negative times 5 times negative 5, which is going to give us a positive 25. So we know our vertex is at negative 1, positive 25. Now the last thing we can do is think about our y-intercept. We multiply the numbers. We got positive 6 times negative 4, which gives us negative 24. Then we got a negative out front, so we got to flip the sign there. So it'd be positive 24. So we could find our y-intercept easily as well.